called as negative acceleration, or you can say it is nothing but the deceleration. Okay, so you can either interpret in terms of the speed or in terms of the acceleration. This is the reference slide I have attached over here. The slope of the speed time graph for the different lines is shown over here. So between A and B here, between A and B, we can see the speed is clearly decreasing, or we get the negative acceleration, that is also called as the deceleration. So here we can write down speed decreases, or that is nothing but the deceleration. Deceleration is nothing but the negative acceleration. Okay. From B to C, we can see here this B to C, the speed is having the constant value. This is nothing but the horizontal value. So speed is constant. Speed is constant. Now from C to D, here you can see from C to D, the speed is increasing with the steady rate. So we will get here the constant acceleration. So we can write down here the speed is increasing. That is nothing but acceleration. Now the part B of the question here. Calculate the distance between the start of the town and the end of the town. So we know that the speed time graph, the distance is nothing but the area. So speed is distance by time, distance is speed into time, which is nothing but the area under the curve. So here you can see it is nothing but between the start and end of the town. At point B it is the start, at point C it is nothing but the end. So we have to calculate the area under the graph. Here I can show here with the red line. This is the start from the B. So you can see this value is nothing but the starting point. This is the starting point basically, and this one is the ending point of the town. So between these two lines we have to calculate the area, and here you can see this is nothing but the rectangle we are getting. This particular rectangle is the area which gives you the distance. So here I will write down first of all the distance is equal to speed multiplied by time. So that is nothing but the area under graph. So here area under graph is nothing but the rectangle. Area of the rectangle is base into height. So we need to know what is the base and height of this rectangle. So here you can see there are 10 divisions between this 10 to 20, and this is nothing but 18 division you can say. So time over here it is nothing but I can write it is nothing but 18 seconds, and here the time is nothing but about this is a second division, so time is nothing but 42 seconds. So this one is nothing but the base of the you can say the rectangle, that is nothing but the length of the base, you can say the 42 minus 18, that will be coming out to be around 24. And on the y-axis you can see this is nothing but our height of the rectangle. This value is coming out, this is close to this line, and this line you can see this is nothing but about 13 meters per second. Okay, because here there are 10 divisions between the 10 and 15, so each two division is nothing but 1 meter per second. So these are, you can see these are about 6 divisions. So this 6 divisions means the increase of 3 meter per second, so it will be 13 meter per second. So height of the rectangle is 13 meter per second, and the base is nothing but about, this will be 24, that is 42 minus 18. So here we can write down the base of the rectangle, that will be 24, height is about 13. So if you calculate this value, 24 multiplied by 13, that is coming out to be 312 meter. So that is nothing but the distance between the start and the end of the town. So it is nothing but 312 meter. Here you can see part C of the question: calculate the acceleration of the car between C and D. And we know that in the distance, sorry, speed time graph, the slope of the graph is nothing but the acceleration that we have calculated many times. Between C and D, we have to calculate the acceleration. So I can select any 2 points here. For simplification, I am selecting this point C and this point D directly. So the slope of this line we can directly calculate. So here you can see this will be our initial velocity. Initial velocity will be here 13 only. The initial velocity is nothing but the 13, and the final velocity at point D. At point D, it is nothing but about 31. Okay, it is nothing but about 31. So final velocity, you can say it is corresponding to point B is 31, initial velocity is 13. So here initial time is 42, and the final time here with respect to point D. So the final value corresponding to point D is coming out to be around this point. So about this point, it is nothing but equal to 54. Okay. So the change in time is nothing but from, if you select point C to D, the change in time is nothing but this is nothing but 54 minus 42, that is coming out to be around 12 seconds. And on the y-axis, you can see from point C to D, it is coming. This is nothing but this much difference will get 13, and from 13 to 31. So 31 minus 13, that is coming out to be around 18 meter by second. So we know that on the graph we have to select any 2 points. We can select any 2 points on this CD line. So I'm selecting the two extreme points C and D. So we should know the speeds corresponding to D and C. With respect to C, it is 13. With respect to D, it is 31. So difference is nothing but 18 meter by second, and the so time with respect to C and D is 42 and 54. So difference is nothing but 54 minus 42, that is nothing but 12. So the change in time is 12, change in speed is nothing but 18. So here, so we can write down over here the acceleration is nothing but equal to the slope or the gradient of the graph, slope of the graph, or that is nothing but the change in speed divided by change in the time. So here we can put the values directly. The slope of the graph is nothing but the gradient is nothing but change in speed, that is nothing but 18, divided by change in the time, that is nothing but the 12. So 18 by 12 is coming out to be 1.5 meter by second squared. So this way we can calculate the acceleration. So that is coming out to be 1.5 meter by second squared. We can also write down the speed acceleration is nothing but the, you can also put the value, write down in terms of the equation, that is the final velocity minus initial velocity divided by the change in time. We can consider that is nothing but t. So here change in speed is 18. The time given is nothing but 12 seconds, or time taken is nothing but 12 seconds. Now the part D of the question is state how the graph shows that deceleration of the car has the same numerical value as the acceleration. So whether we calculate the deceleration or the acceleration, deceleration is nothing but negative acceleration, that is to be calculated with the slope only. So if you see this line, if you calculate the slope of this line AB, that is nothing but deceleration, or if you calculate the slope of this line, that is nothing but CD, then you can see the slope of both the lines will become same. So only the difference For AB we will get the negative value, here for CD we will get the positive value. That will be